In this lesson, we are going to talk about environment and staging. What do I mean by that? Until now, we put a very simple environment. We have only one directional light. We also have an ambient light. So this is what we did in the previous lessons. We are going to discover many environmental features available and how to implement them in React 3 Fiber. We see that it's not just about a few lights. It's also about shadows. It's also about environment map, different way to add them, some presets, some automatic stuff, some helper that help us do that super easily, and some new features that you will discover along the way, made possible by React 3 Fiber and the many helpers you're going to see. So about that setup that you can already see on my screen, obviously you start the project, npm install, npm run dev as usual. What to say, there is a sphere, a cube, a green floor. Okay, that's great, so that we can see the shadows, things like that. We can see some stuff in the back when we are going to add that. The cube is already rotating so that we can test like if the shadow is being animated. You will see that later. I've also added a perf so that we can keep an eye on performances. We see that when we add some stuff like the shadows, the time it takes to render the scene will be a bit longer. I also added Dray. And the only thing we use from Dray, I think, is the orbit control so that we can rotate around. So not much, but we have a good base. First, not that interesting, but we need to talk about that because there are multiple ways of doing it, is the background color. And we already set the background color in previous lessons, but I need to talk a bit more about that and the different ways of doing it. Yeah, by the way, we're going to see multiple ways, something like 3 or 4 different ways of setting the background, just a background color for now. They are all viable. You do the one you prefer, but in some very specific situations, like when we use post-processing, it's better to use one or maybe the other. We will see that in the post-processing lesson. So the React 3 Fiber post-processing lesson, which is a bit different than the previous post-processing lesson. So, like we did in previous lessons, we can set it in CSS. We're going to go fast on this one because we already did it and it's not that interesting. But let me remind you that the background here is actually transparent, and what we see is the background of the page. So the white you see there is no object, no mesh, there is not a plane behind it. So what we see is the page behind. Meaning that if you want to add an image, if you want to add text, other HTML stuff, you can do it. You just need to make sure that it's on top of, it's behind your canvas, and you will see it there. And the test we did earlier, we can do it again. So we can change the background, let's say on this one. So it's going to change it on the HTML, on the body, on the root. You don't need to do it on all of them as long as it's behind the canvas. But anyway, let's do it. We can put like background red in the CSS. And as you can see, the background is red. All right, so cool, yay. So we already saw this one. Let's get rid of it. I just wanted to remind you, you can do that. Next one is by using the set clear color. And you probably know about this one because it's the native way. Using the renderer, there is a set clear method, and we can call set clear method to put kind of, when WebGL will render the scene using 3JS and stuff, it will first put a color. So it will kind of mask everything with one uniform color, and then it will start drawing the different objects, and we can decide what we want on that color. Okay, so we need to have access to the renderer only once when it has been created. All right, forget about doing it like on the use frame. You don't want to set the color on each frame. It would work, but we don't want to do that. We just want to do it once when the scene has been created. And we can do that. So you will go to the index.js file over here, and you will add a new function. So I'm going to call it created like this. And this function, we want to call this function so that we put some instructions in it. We want to call these functions once the canvas and the renderer and everything, the scene is ready. They are all created. And we can do that by adding an attribute here. So it's in the opening tag of the canvas. And we do onCreated like this. And we just pass the function we have created right here. Right? So we put maybe a log there. So console log created like this. I'm going to save. And as you can see, our instructions there in that function have been called well, it seems to be at the beginning, and it will be done once the canvas is ready. So it's working. In there, we will be able to set the clear color on the renderer. So how do we access that renderer? In the parameters, in the arguments there, we can add state. And you remember this one, we saw it when we use the use3 hook, and when we use the use frame hook, and we get access to the state, which contains a bunch of stuff like the camera, the GL, some other function like the scene, the clock, etc. So we can access it, and we can access the renderer as state.gl. So it's the GL property, and that's our WebGL renderer, and it's native 3GS WebGL renderer, meaning that we can call the function, the set clear color function on that one. By the way, I don't think we did it until now, but you can destructure this if you want. Like if you just want the GL, you do that. So this is just native JavaScript. When you have an object and you just want specific properties from it, you destructure it like that, and you get that property there. Okay, we get the same result. And on this one, we can call the GL, and it's the set clear color method. And here you can pass, well, anything. You can pass red, you can pass hexadecimal like this. And don't forget that you can also specify the alpha. And by default, I think the alpha is 0. So we want to see color. So we are going to put the alpha at 1. We do this, and we get our background, uniform background color there. So it's not the page. Okay, the color you see here is WebGL. It's not the page. If you put stuff behind the canvas, you won't see it anymore because the canvas is opaque. All right, nice. It's just another way of doing it. And there are two other ways of doing it. We can also do it on the scene. I don't know why there are so many ways. They're actually a bit different at the end, but I don't know. There are many ways to do it. We can do it on the scene background. To get access to the scene, so we are going to forget about the set clear color. To get access on the scene, we can also do it from the state. Okay, remember we had the state there. The state also contains a scene property. We can log it, get rid of the set clear color, and we get access to our scene. Okay, it's a classic 3JS scene. No trick here. And we can do on that scene, it's on the, what's the name? The background property. So it's background. And this time we need to pass 3 color, so an color instance to it. So we can do new 3. I did a mistake here. What's the mistake? Or you probably read it from below. We need to import 3. Okay. So first we're going to import 3. I'm going to do it, here. You know, I like to have like dependencies imports, the style separated too. The style usually I put it at the end, but why not? So dependencies there, so things that comes from node modules, and then my custom class, like the experience that come from the same folder. But it doesn't matter. So import everything as 3 from 3. It's the usual. And now in this file, we can use 3. So we create an instance of color. Don't forget the new here. And in there, you can pass anything you want. So I'm going to do red again. And it's working again. Okay, we get the same red. And you can put anything there like purple or whatever, it's going to work. One more way of doing it. So we go quite fast on those, but because that's not super interesting. But this one is kind of interesting, but that's a different way of, this time we are going to use like really React 3 Fiber to set the color without targeting like native 3GS like we do right now. So first, we are going to create the color directly in the JSX. How is it going to work? First, we're going to clean a bit because I want to get rid of what we did there. So remove the attribute there, remove the function there, okay, because we are going to see a different way. So right now we get the transparent background again. And in there, let me see. Yeah, okay, we clean that. Yeah, that's it. In there, like before the experience, you can put it after. I'm quite sure it's going to work. We're going to create a color tag like this. Remember that React 3 Fiber implements all 3JS classes. So everything that is inside the, by the way, we can remove also the import, but everything that is inside the 3 variable are available as instancing like that. So when we do 3 color, we can do new 3 color. Remember, we did it a bit before, like 3 color. We can create that color inside React 3 Fiber, so inside the GSX, the renderer of React 3 Fiber, by doing just that. This will create the color, okay? And we can pass it an args. So remember, we needed to pass, I don't know, something like red. Don't put that code here. It's just an example to illustrate what we are doing in React 3 Fiber. Just do this one here. And we pass, so we inject something and we pass an array. Remember, the args, it's always an array. I do that mistake a lot. Like I try to send red, I do it like that. Classic mistake. It has to be an array. Like this, so an array with only one parameter, only one item, and you put the color there. And this will result in exactly the same thing here. But wait, if we do that, you can try. Let's put, I don't know, hexadecimal. There is something missing here. We save with the right amount of values in there, of characters in the hexadecimal, I mean. No difference. Yes, because we created a color, but we didn't assign it to something. Remember the previous versions of adding a color? We did scene.background. How can we do that from here? Maybe you remember, we saw that in I think it was the first lessons about React 3 Fiber. We need to use the attach attribute so that it attach to something that is above, and we specify the property we want to attach it. Let me show you. We put attach color. I want you to attach to this property of your parent, and we're going to attach it to the background. And check that, it's working because the only parent above this color is the scene. I know we can't see it, but it's like if we had this. Don't do it, it's not gonna work, but it's a bit like that. We have our experience and the color in the scene, and we say to that color instance to attach to the background property of the parent. So it's gonna be the background property of the scene. Okay, the scene is implicit right here because there is nothing above it. We just save and it's working. And that's cool because we stay in React 3 Fiber. We don't split between native 3JS and React 3 Fiber. It's okay to do some native 3JS, but it's better to have everything in React 3 Fiber when possible so that you don't mix different techniques. Okay, cool. Next. Okay, we did that. Yeah, by the way, you can also put it in experience. So where is it? There. You can also put it there if you want, so that you have everything in the experience and minimal code in there, in the index.js. So I'm going to put them in order. I'm going to remove the style.css. But see, I've removed it from the index.js file, and I put it in the experience. And you might think that, is it the same parent? Yes, it is. There is nothing above the color. This is a fragment. It's not a group, an object, or whatever. The only thing above the color is the scene. So the color will be attached to the background property of the scene. Cool. Let's move on. Yeah, let's change the color, by the way. Ivory, why not? It's kind of egg color. Yeah, I like this one. Okay, nice. Let's move on. So those were how to set a color. Later, we're going to put more stuff in the background, cooler stuff in the background, but that's a good start. Let's talk about lights. We already added 2 lights. So if you check there, I'm going to close this. Yeah, we have a directional light, we have an ambient light, and there is no trick here. If you want to add a spotlight, you add a spotlight, and you play with the position, the intensity, the color, whatever. If you want to add a rect area light, you add a rect area light. All the lights are supported. You have nothing special to do. So we are not going to see them because it's going to be super boring, and you can probably do it already on your own, but we have more to talk about when it comes to lights. Yeah, first we can talk about the light helpers. Using the helpers, you know, it's to figure out where is the light exactly. I'm not sure when I try to create a cool scene. Where is my light? I don't understand. Well, usually you add a helper to really figure out where is the light and how it's acting, especially if you animate it. So how do we use helpers when we are in a React 3 Fiber context? There is a helper. I'm going to say that a lot. So we have an issue. There is a helper most of the time. which is use a helper, that from Dre, obviously. But first we need the reference to the directional light. You can try to do it on your own. We have created a bunch of references in the previous lessons. So let's go. We are going to import useRef. We already have useRef because we are animating the cube like that. So don't import useRef. We already have it. And we are in the experience.js file, by the way. And we're going to create directional light. So const directional light. I'm not putting the ref at the end of the variable names so that it's a bit shorter and it totally makes sense. It's the directional light. So, okay, we have the ref and then we associate it. The ball just came back. You know, it's a little bug. You had to reload to, I don't know why these spheres always disappear on hot module replacement and sometimes it goes back. It's thinking on its own. That's weird. And then we associate it with the directional light. So let's go. We are going to add the helper on the directional light. So ref, and we send the directional light, yeah, like this. All right, cool. So we now have a reference to it. And now we need the use helper because we want to add a helper for the directional light. So it's from Dre. Make sure that you add it in the right import. So it's over there. And we do use helper like this. All right, no error, seems to be fine. When we want to use helper, the first parameter is the reference. So we already have the reference. And the second parameter is the helper class we want to use. Meaning that you can use, you probably remember from the 3GS documentation and the previous lessons that there is a bunch of helper. There are helper for specific lights. There are helper for the objects. There are helper for the cameras. And you need to specify what helper you want to use. But first, we need to import 3GS because they are stored inside the 3GS dependency. So I'm going to import everything. As always, you can just import the one that you want, if you prefer, from 3. And in there, we will have access to all the helpers. Then we get there, we can put the code over there. Let me check. Yeah, let's put it there so that everything is separated. Usually I prefer to have all the references together at the top, but I'm going to keep them together here, the helper and the reference. And we can call use helper like this. And we can call directional light, so that's the reference. And then we can set the 3.directional light helper. That's the helper from the 3 dependency. We want to use the directional light helper. And we can put 1 at the end. Those are the parameters for the helper. It's the size. We can test a different value, but first set it to 1 and move like this. You can't see it much because it's white, since the light is white. And if you put 2, well, it's bigger. Okay, if you put 0.5, well, it's smaller. I hope you can see it on the video. It's quite a thin line. Let me check if the zoom is right. Yeah, the zoom is 100%. Let's put back 1. And that's all. And that's the way of adding a helper. We're not going to do all the helpers with camera, the various lights, etc., the axes and stuff, but that's the way of using the helper that will be update themselves when it's needed. Nice. Next, we're going to talk about shadows. Quite a big section, shadows, because we have a lot of different shadows made available to us so that they look better. If you just want to add shadows, like the basic 3GS shadows, you will see it's super easy and convenient, and it works with just a few lines of code to add to our JSX. But we are going to go much further because it's so easy. Let's go further. Let's go further, sorry. So shadows, we're going to start with the default shadow, okay, and then we're going to use some helpers from Dre that will make the shadows pop and look so realistic. You will see it's so cool. The default shadow. First, we want to activate shadows. If you remember from the previous lessons, we need to do it on the renderer. In the case of React 3 Fiber, so go on the index.js file, we just need to do shadows there. That's all. And the only fact that we added it, we can add true, but that's the same of just adding the attribute. So if you just add the attributes, it's considered as true. We do that. No, we don't have the shadows yet, because if you remember from the previous lessons, we need to say that this mesh is casting shadow, this mesh is casting shadows too, and this one is receiving shadows, and this one is both casting and receiving shadows, etc., etc. So React 3 Fiber won't do it for us because it's up to us to decide which one are casting and receiving shadows. And the goal is to use it as less as possible. Like right here, those two objects should cast shadow so that we see the shadow on the floor. They should not receive shadow unless something goes above, or unless you want the cube to cast shadow on the sphere, but it's a bit far-fetched. And the floor needs to receive shadow, but should not cast shadows because there is nothing below. That's the rule, okay? For each object, you need to decide on that. But we also need to set it on the light. We need to ask each light to cast shadows or not. So we are going to do it there. I like to keep the ref as the first attribute. By the way, you can add line breaks when the line gets a bit too long. Not going to do it right now, but maybe later. So cast shadow on the light. You decide your lights should cast shadow or not. Those that support shadows, like the ambient light doesn't support shadows because it's coming from everywhere. Doesn't make sense. So the light now is casting shadow, singular. And next on the objects, we are going to decide if they cast shadow or not. Let's do it on the orange sphere and the purple cube. So yeah, those ones. We're going to do cast shadow on the first two meshes, so the sphere and the cube. Still nothing on screen, but on the floor, we're going to ask the mesh to receive shadow. And we have our shadow. So easy. I mean, maybe it took me 5 minutes to explain it, but because I was explaining in details, but it's 1, 2, 3, 4 words added to the explainer.js file and 1 word added to the index.js file, and we have shadows. That's so cool. But we are going to go a little further, obviously. Yeah, by the way, if you check the render time, I don't see much of a difference because my canvas is super small. It's just like a quarter of my screen. So those numbers are not that relevant, but check that. You might see that the time it takes to render is a bit longer because 3JS is rendering the shadows, you know, with shadow map, etc. We're going to talk a bit more about that. Baking. I'm not talking about baking like we did in Blender. I'm talking about baking in real-time rendering when you just calculate the shadow once at the beginning and then you stop calculating the shadow because maybe your environment doesn't change too much. Like if the cube were not rotating, it's just a scene, maybe you want to bake the shadow, like calculate the shadow and keep it and stop rendering the shadow, and it's going to be better for performances. So if you have a static scene, bake the shadow in real time. I'm not talking about Blender baking. I'm talking about 3JS baking. So how do we do that? There is an helper for that. It's a bit far-fetched, but why not? There is an helper just to ask the renderer to stop calculating the shadows. And the shadow will be rendered only once. So inside the experiences.js file, we need to import a new helper. We are going to have a lot of helper here. By the way, you can write it like that. Okay, I'm not going to do it, but you can import stuff like this so that everything fits like on the width. If you think it's better, please do it. So we import bake. How do we write bake? Bake shadows like this. All right, cool. And then we add it to the scene. So yeah, we add something to the scene to ask the renderer to only bake the shadow once. It's a bit weird, but it works. Our sphere is going to the toilet or whatever. Okay, the sphere is back. I really wonder why the sphere keep leaving the scene. And as you can see there, the shadow just stopped moving because it has been calculated only once at the beginning, and then the shadow map is being used again and again. It's the same shadow map, and we don't re-render it on every frame. And as you can see, the cube is not moving. The shadow cube is not moving anymore. So if possible, at the baking, if your scene is moving because, I don't know, there are birds flying and the player can move around, then you can't bake it. And yeah, obviously it takes less time to render. A bit less because still your shaders, the mesh standard material need to use this shadow map, but it's already much better in terms of performances. Configuring the shadows. So we stay on the native 3GS shadow for now, but we are going to configure it because check that. Maybe it's not perfect. See that? We can see some stairs. I don't know if you can see with the video compression, but maybe you want to improve that. Or maybe you have a much bigger scene. So the scene goes there, 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 there. You have some objects. You will see that it's cut, all right? Because the shadow is rendered on a very specific area. So you need to configure the shadow. How do we do that? By default, it looks good, but we're going to tweak it. Quick reminder on how 3GS handles shadows. Each light casting shadows, so it's the case for our directional light, will render the scene in a specific way and output it in what we call shadow map. All right, that directional light, when on each render, or unless on in this case it's just a big shadow, so on the first render, it will put an orthographic camera instead of the light, and it will render the scene and replace the material of everything just to get information about what is in the scene and how far there are, and this is called the shadow map. Then this shadow map will be used on each one of the material, on each one that is receiving shadow, yeah, just the one receiving shadow. So for us it's on the floor. All right, cool, that's just a quick reminder. Meaning that 3GS will do a render, all right? The WebGL will do a render, meaning that there are pixels that will be rendered. And sometimes the quality is not good enough, okay? It's just like rendering something. If the quality is not good enough, you start to see that. I'm talking about the resolution, like how many pixels are being used to render that shadow map. So we can control that, and it's kind of easy, but if we use pure JavaScript, so pure native 3GS, you need to do that. So the directional light, we access the shadow property, and then we access the map size property inside the shadow, which is a vector2. And on the vector2, you can call set. All right, on the vector3, we can call set. On the vector2, we can call set. Set is available on most mathematical classes. And then we provide the X and the Y. All right, that's the native way. But how do we access this in React Free Fiber? You might think that we can do it with the directional light reference. Yes, we can, but we're going to do it a bit differently so that we discover something. We can access those deep properties. So it's not just the property of the directional light. It's not just side, it's inside something. We can access those using dash keys. So as attributes in there, we can access the shadow and then the map size on the attribute of the directional light. I'm talking about this tag here, by separating them with dashes. What do I mean by that? The best way is to just do it. So I'm going to add some line breaks because this one is getting a bit too long. So I'm going to put this one here, this one here, this one here. You don't have to do it, but it's a bit recommended. Like if it's too long, you're going to get lost a little. And I'm going to put the shadow at the end so that we have everything related to shadows at the end. All right, so I just put line breaks and change the order of the attributes. And I say that we want to access the shadow property. And in the shadow property, there is another property, the map size, and we can access it directly using a dash. And then map size in camel case. And in there, we want to call the set property, the set method, sorry. So the set method, it's a property, it's a function property. So it's a method. And we can do that by just sending an array like that. And we can provide a better resolution, like, I don't know, 1024, like this. And check that. Yeah, that's better. You might need to get a little reload because it has been baked with the old resolution. And now there is a new resolution, doesn't make sense. So maybe give it a reload. And as you can see, it's sharper. You want more? You can just do multiply by 2 or 2048. And check that, I give it reload, and now it's super sharp. See, I need to zoom in a lot to see it. Be careful, the bigger the resolution, the longer it takes to render, and the worse the performance is. But those are native shadow stuff. We are not going to spend too much time on it. And we can put 1024. All right, nice, cool. We can do a little more. If you remember what I said earlier, the camera, the light is, the shadow map is being rendered by a camera. It's an orthographic camera. If you remember the orthographic camera, it's doing kind of a parallel render like this and like this, okay? And this area can be set. So currently it fits perfectly with the scene. All right, we can imagine that we put ourselves instead of the camera. It's a bit like that, and it's usually a square. Okay, like this. So we render maybe something like that. So as you can see, everything is fitting nice. But it's not always the case, especially if you have a big scene and it goes far on the side. So we might need to control that. And we are actually going to do the opposite. We are going to make the render smaller so that we can make sure that it's working and see that the shadow will be cut right here and right here. So we are creating a bug. How do we access those? Well, in native 3GS, it's the light, then the shadow property, and then inside the shadow property, just like we did for the map size, we have access to more. We have access to the camera. That camera that is being used to render the scene as for the shadow map, we have access to it. So it's going to be the light, the shadow, the camera, and this camera we have some properties. And for orthographic camera, you know, it's the top, right, bottom, or up and down. I don't remember. It's top and bottom. Yeah. Top, right, bottom, and left. And you can control the distance like that. So just the same way, shadow dash camera, because it's the camera property inside the shadow property. And then it's the, we're going to start with the top property inside the camera, property inside the shadow property of the directional light. And then we can provide different values. And I'm going to provide a very small value. I think the default is 5. I'm going to provide 2. I'm going to do it on each side. So let's do top, right, bottom, left. While this order, the order is not important. You do whatever you want, but I like this order because, you know, it's a clock. It does like this. It's my way of remembering the order, always having an order that makes sense. People like to do top, bottom, left, right. I don't understand why. Maybe it's some cross thing or whatever. But I like to do like a clock, always a clock. It's probably inverted for you. Anyway, you get it. I'm going to reload and it's not working. Oh yeah, I did a mistake. So top, I put 2, right, I put 2, but bottom, I put 2, so it's going up again. So no, I need to put -2. And left, -2 again. Small mistake, sorry. Now it's working, give it a little reload. And as you can see, the shadow map is too small. So see that light here? This is the one casting shadow, and it's doing 2 units on the right, 2 units on the left, and if you put it there, 2 units on the top, 2 units on the bottom. So it's casting shadow here, but it's cut right here. The rule is simple. You make it as small as possible without having the shadow being cut. Because if you put like, I don't know, if it's too big, I'm going to put 200 so that I'm sure it's not an issue anymore. Where you get low resolution. I mean, you have a specific resolution, so it's 1000 by 24 on the X and on the Y, and you spread it like that, so you get huge pixels. It creates soft shadows, but maybe that's not what you want to create, so it's up to you to decide on what you prefer best. If you want sharp shadows, you make this value as small as possible without cutting the shadow. Like this. 5 is just fine. By the way, I forgot to tell you, but we can also control, you know, the near and the far. The near and the far, you know, it's kind of the clipping thing. When some object, it works with any camera. When an object is above the far value, it will start disappearing. Like if you have an object that goes away, you can't see it. It comes back, you see it, you see it, you see it, and you can't see it. It will be cut. And there is a near, the far value, and there is a near value too. Don't put extreme values. It's going to create some Z fighting. Just put something that fits your scene. So I'm going to do, I'm going to duplicate the attribute. I'm going to put near to 1. Usually put like 0.1 so that objects can get quite near the camera. And for the far, I'm going to put 10 units. All right. So if you see from the side, my camera, my light is over there. I put 1, so it should be over there. And I put 10, so it should be over there. All right, so my scene is fitting perfectly in there. And if I put something too small, let's see if I can yeah, see, I put 5 units from the directional light. It's cutting the shadow right here. So let's put 10. All right, next, we are done with the native shadows. As you can see, it was super easy. But now we're going to discover more shadows, and it's going to look super good. We're going to talk about soft shadows. Oh, can we have soft shadows? I mean, that's too sharp. In real life, we don't get that result. Does it mean we can have soft shadows where the shadows get like kind of blurry when it's far away from the object? Yes, I have good news. It's possible. There is a downside. You will see. The default shadow are too sharp. Yeah, that's what I just said. There are multiple ways of softening them, and we are going to discover one technique called the percent closer soft shadows. Why percent? I'm not sure. Anyway, PCSS. Why not? PCSS will make the shadow look blurry by picking the shadow map. So it's the same shadow map. We are going to use the initial shadow map that we created right here. It's going to pick this shadow map, so inside the shader, depending on the distance of the object, depending on depth information. And it's going to pick it further away from the initial position, depending on that distance. So in the end, we see that it will look soft. And the further away the shadow is from the object casting the shadow, the softer it will get. Sounds super simple. Well, the downside, we see its performances. Also, it's hard to tweak. It is achieved in 3GS thanks to Spider Sharma 03. I put just the GitHub because thank you Spider Sharma 03 for adding this feature. And actually you can see an example in the 3GS website. As you can see, the bows that are far away from the floor are softer, and it works on every object, so it's super cool. And we can use that. And it's implemented in React Fiber thanks to Dre. Yeah, by the way, implementing this solution implies modifying the shader chunks. All right, 3GS shaders are going to be updated directly. So you're going to kind of change the behavior of 3GS. So it's going to be applied everywhere, and it's going to mess up with the shader code. So be careful. You might create some bugs, especially if you are modifying the shaders too. For some reason, I don't know, you are doing a custom material based on an existing material. So yeah, that's kind of another downside. So Dre comes to the rescue with a helper named Soft Shadow. So we're going to import that soft shadow. But this soft shadow, to make that soft shadow helper work, we are going to call it once outside of everything, because this helper, this function, will modify the shaders. And we want to do it just once at the beginning. So we're going to modify 3GS. I mean, this function is going to modify 3GS, and we want to do it just once. So a lot of talking, let's do it. So we're going to import that helper. So soft shadows. So import it from React 3 Dre, like this. We have it. And then in here, we're going to call it and check where am I right now. I'm outside of the experience. You just want to do it once here. You don't want to do it in there, because what you put there will be called every time the experience component is being re-rendered. Okay, so let's go. Soft shadows, and we are immediately going to provide some parameters. We need to send an object like this, and just put the same parameters as me. We see that it will look good. So 3.75 for the size. We put 0.005. For the near, we're going to put 9.5. I said 0.5. Samples, we're going to provide 17. And rings, we're going to provide 11. I save, I reload the page, and check that out. I hope you can see. Enjoy soft shadows. It's working. It's working. Yay, it's so good. And it looks super good. But check that. Yeah. So it's still okay. 1 millisecond to render a scene is pretty good. It depends on your computer. It should be fine on your computer, even if your computer is not very powerful too. But it took a bite on the performances, and it takes, I don't know, maybe 3 times longer to render the scene, something like that. So that's the main downside, but it looks so good. So if you have a simple scene, it's okay. By the way, this one is being done on the baking the shadow doesn't help that much, because this softening thing happening here is done on each frame for the object that are receiving the shadow. So in our case, it's on the floor. So baking doesn't help much. By the way, we can remove it, because see that cube is still baked. This one is not animated, so we can remove the bake shadow like this. Up, I reload, and now it's rotating. Nice. So you can have dynamic scene. The performances are almost the same. We just need to re-render the shadow on each frame, which is just fine, especially with a simple scene like this, but it's working. The parameters we are sending to the soft shadow are used directly in the compile shader, and modifying them implies recompiling all the material shaders. That's kind of the issue too. See, I provided some parameters. I'm not going to go into details with those. I just spent maybe half an hour testing until it looks good for me. You can check, like I put the links to the library. You can try to understand each parameter, what it's doing. Be careful if you add to some of those parameters, the performances are going to get worse. Something can get like you can get a softer shadow, you can get a sharper shadow, but some of those will kind of impact the performances. So be very careful with those. You can't add those to that GUI or lever or something like that, because those are being used to compile the shader once and for all. So those are just used once, and if you want to test different values, you have to change it and reload, okay, which is a bit complex. Maybe there's a way to recompile the shaders, but it's going to mess up everything. So yeah, you just need to test until you're happy. Nice. Yeah, I already said about that. Next, shadow. So the soft shadow is really cool, but we're going to see other shadows. The accumulative shadow. This one is really cool too. There are some downsides. Again, there is always downsides. Otherwise, we would have them always on. But this one is really cool. If you can use it, you will see such a good result. Be careful. This section is quite long because there is a lot of parameters on the accumulative shadow. But it's so cool. Really try this one. The accumulative shadows will accumulate multiple shadow renders. Accumulate kind of makes sense. And we are going to move the light randomly before each render. Okay, imagine right now we are doing on each frame, we are doing one render from the one shadow render from the light. This time with the accumulative shadow, we are going to do multiple renders, and we are going to move the light a lot of time, and then we are going to recompile those shadows to get a soft shadow. So if an object is near the floor, moving the light will not blur that shadow a lot. But if an object is far and you move the light, then the shadow will be cast there, and you will get a soft shadow. That's the idea. And we're going to move the light randomly. And actually, it's going to be multiple lights, and we can control how much the light jiggle. Oh, it's so cool. We have so many parameters. So let's go. Let's do that. Yeah. First downside, the accumulative shadows can be rendered on a plane only. Too bad. So that's the first issue, but that's great for the floor. All right, you can just put it on the floor, and you will have a beautiful floor with beautiful soft shadows, and that's already pretty good. And for the rest, you can maybe use default shadows. Since the accumulative shadows will be a shadow on its own, all right, this one will be an object that will kind of show a shadow. So it's going to be for the floor. We should deactivate the shadows on the mesh corresponding to the floor, all right? Because we already have a shadow here that is being created on the floor. We are going to add an object that will create the shadow, that will show a shadow, and we don't want double shadows. So we're going to remove it from the floor. So let's go. On the floor, where's the floor? It's over there. Yeah, that's the one with the green yellow color. We can remove receive shadow, all right? And we lose the shadow there. Okay. Next, since we can't see the previous shadow we have been creating, we can remove the soft shadow, okay? Let's go. We don't care about this one anymore. It was just a demonstration. You can add it on your project, but for now we are going to comment it. All right, so let's check the performances. Performances are fine. Goodbye the soft shadows. Next, we can import the accumulative shadows. So let's go, accumulative shadows. As you can see, when I import directly, you can try to write it directly on the JSX and hope it's going to get imported by VS Code. Or you can, I put a space here, so that here I can put accumulative, and then I have the autocomplete like that. All right. And if I don't put that space, if I stay right here and I write accumulative. Well, it doesn't make sense because there is this whole word that doesn't match with one of the dependencies from React 3 Dray. So I put a space, accumulative shadow, and now I can get it. Anyway, you import stuff the way you want. Accumulative shadow, all right, cool, from Dray, make sure it's from Dray. And then we go to the scene and we can put it, I don't know where to put it. I'm going to put it, yeah, after the lights. Or before the lights. Yeah, let's put it before the lights. Accumulative shadow, and I'm going to close it. I'm going to have a closing tag because we are going to put stuff in there. We save, the sphere is gone. Come back sphere, and if you give a reload, that's our accumulative shadow. So it's not working yet. We need to do some changes. First, it's at the origin of the scene, so right here. We're going to put it right above the floor. Okay, the shadow that will be created on this one will be a transparent. So if the shadow will be opaque, but the rest will be transparent. So we just need to put it right above the floor, not exactly on the floor because it's going to create Z fighting. You know, when we have two planes on the exact same position, the WebGL doesn't know which one should be on top of it, and they are fighting to get rendered. So we're going to put it just right above the floor by setting a position to, it's going to be 0 minus 0.99, 0. Okay. We reload and it's right above the floor. Okay, so that we prevent Z fighting. If I zoom in, so we can still see the floor right below. Okay, nice. Next. By the way, as you can see, it fits our scene perfectly. That's pure hazard because if you change the scale, like I don't know, you have a smaller scene, you can put 5, give it a reload, and now we have this. All right, so make sure it fits your scene. So for us, it's 10. I'm going to leave that attribute, but the default value is 10, which fits our scene perfectly. Then we need to provide lights. Yes, the accumulative shadow won't take the light from what we already have in the scene. We have to provide the lights. It's kind of doing its own thing on its side, so we have to do it separately. So let's go. We're going to create a directional light, like this. We can auto close it, and we're going to provide the same attributes for the position and the cast shadow. So position, we're going to give, I think it's 1, 2, 3. Yeah, 1, 2, 3. That's the same as we had here. And for the, and I think we need to provide cast shadow, which is a bit weird. If we put it in there, it's that we want it to cast shadow. I don't know, maybe it's to make sure that it's work with 3GS. Yeah, probably, I think. So cast shadow. We save, give it a reload, and we get this ugly shadow. Don't worry, we're going to fix that soon. Yeah, give a reload every time. Later, we're going to replace that directional light by a better solution. Okay, it's coming. We have our shadow back, but it looks worse than before. What did we do wrong? The accumulative shadows is doing a lot of shadows render. As I told you earlier, it's going to render using that directional light. It's going to render shadow maps and it's going to accumulate them. So our light is creating shadow maps, but it doesn't move. So we are rendering, and the shadow map here is taking those shadows, which are exactly the same, and accumulating them. So it looks bad. It looks super dark here. So we need to move that light randomly. We could do it ourselves. Could be funny, like how can we move the light randomly? We put some parameters and we add them to Leva and stuff. That could be super interesting, but we have so much to see. We're going to use a helper, thanks to Dray. There is a helper named randomized light that will do exactly this. And randomized light will create one or multiple lights. So it's not just one light. We can ask to have just one light, but we can also provide multiple lights, and it will make them jiggle randomly. I wonder if this helper can be used for something else than the accumulative shadows. If you have an idea, just saying to me, maybe you are creating some party mood for your scene, and there are lights everywhere, and people are dancing and stuff. I don't know, but for me, the randomized light has been made for the accumulative shadows. Anyway, let's import it. So randomized light here, randomized light from the React 3 Dray, and it's singular randomized light. And then we add it here instead of the directional light. All right, so I put it there, and I think the cast shadow is set by default, so we can remove the cast shadow. We're going to add a bunch of attributes. Right now we are just trying the default parameters to see what we get. I save, I reload the page, and we get something else. So it's better, but it looks like abstract painting, or I don't know. Check on your computer because the video compression might not show you exactly what I get. So it's weird, and it looks like this one is not moving, so we need to do some tweaking. Don't worry, we can tweak so many parameters. Yeah, anyway, the randomized light has multiple attributes to control the behavior of the light. I think there is even more attributes, but we are going to focus only on those 4 attributes. So first, the amount. We can choose how many lights there is. You can have 1 light that you move a lot, or you can have, I don't know, like 3 lights. You will get a different result. It will take its share on its bite on the performance, but you can decide to have more lights or less light. The radius, so it's the amplitude of the jiggle. Remember that we are moving the light like this. You can move them a little like this, or you can move them a lot like that. So if you move them a lot, you will have a more blur shadow, right? A soft blur, more blur. Yeah, let's say a more blur shadow, more spread shadow. But you will see the different parts right here. Like you can see some shapes, some how can I say, some artifacts. Yeah, some artifacts there. So you have to find the right values. Intensity, so the intensity of the light, why not? And the ambient, which act like a global light, like if a global light was illuminating the whole scene, making only tight spaces and crevices receiving shadows. Like if you increase the ambient, you will only see lights like right here when things are a bit tight, and right here below the cube. I'm just kind of explaining some parameters in case you want to have fun and you wonder what they are doing, but we're going to set a very specific values at some point, okay? Next parameters, yeah, those are parameters related to the lights. So there is already 4 parameters, and there are parameters related to the shadow maps, because the accumulative shadow will generate a bunch of shadow maps, and those shadow maps are the same shadow maps that we have been using until now. So first we can say that we want to cast shadow, do we? No, I think it's by default on, so why wouldn't we create cast shadows? That doesn't make sense. So I think it's on. The bias, remember the bias? We saw this one, I think it was on when we created the hamburger, and we had some shadow acne on the surface of the hamburger when we activated the shadows, and we had to play with a bias that will offset the way it used the shadow map to make sure that something is in the shadow or not. The issue was that the shadow was casting shadow on the mesh, so the bun of the hamburger was casting shadow on itself. So we had to play with the bias to fix that. I'm not gonna go into detail about that. You can fix that if you have some shadow acne. You know, you start to see some shadow lines, like let's say on the sphere, because the sphere is both casting and receiving shadow. You can play with the bias to fix that. It's not the case for us because the sphere is only casting shadow and not receiving shadow. The map size, just the same. We can decide on the resolution. The size itself, so it's the amplitude of the shadow. It's an orthographic camera that will render the scene, and we can decide the top, right, bottom, and left. The near and the far, you know those. It's how near something can be seen in the shadow map and how far. So you need to tweak those just the way we tweak them for the directional light. Finding the best tweaks is complicating, and this is where a debug UI like Leva would be very useful. We've learned about Leva. We're not going to use Leva in this case because there are too many parameters. I'm just going to give you my parameters. But if you want to have some fun with Leva and find a better tweak, you will probably find better values than me. You should add Leva. Actually, I added Leva when preparing the lesson to find those good values. About Leva, don't worry, we are going to use it later for all the tweaks in order to use Leva and have some fun. Leva or that GUI or whatever you want to use, but Leva, we saw Leva in a previous lesson, so let's use Leva. All right, take my parameters and it will be just fine. So I'm gonna have 8 light. I'm gonna set the radius of the jiggle to 1, which is kind of a lot. So it's gonna be a 1 unit. The lights are going to move in a 1 unit amplitude. I'm going to add some ambient so that we mostly see shadows in crevices. Don't worry, we are going to see the shadow a bit everywhere. The intensity, we can set it to 1, not 12, 1. The position is already set. It's 1, 2, 3. And then the bias, just to make sure that we don't get too much like shadows casting on themselves. Actually, this one is not important because we don't have like round surfaces, so it's fine, but I put the bias anyway. We reload the page and we get something like that. All right, it's slightly better, but we have some work to do again. I told you this section is a bit long, but it's worth because it's gonna look super good. We also have access to some attributes on the accumulative shadow itself. So this one here, and we can set the color of the shadow and the opacity. So let's go. It's color singular. I don't know why I wrote colors with an S. The floor being green, I recommend to have something of green, blue shadow, because shadows are usually in real life, well, it depends on a lot of factors, but in real life, shadows tend to look colder. So we're going to put some blue in that value in the color. So color, and you can just provide like an hexadecimal. So 31.6D39. We reload and see it's a bit bluish. You can't see much of it, but it's a bit more realistic. And then the opacity, and I'm going to lower the opacity just a little, 0.8, like that. And I reload, and then we get this. So it's still not perfect. We have some work to do, but it's looking kind of cool. I mean, it's okay. But we are going to do it even better. There are more attributes, so many attributes. The two that we want to see now are frames. How many shadows render to do? Okay, because maybe there is not enough shadows renders right now. Performances are still fine. Actually, there is a reason for why the performances are that good. I have bad news actually, but we see later. But we can accumulate more shadow renders to have a better result. And temporal, which is going to spread the renders across multiple frames. I will explain to you what's the issue with that right now. So this one is, I don't like we see some artifacts because we don't have enough renders. So what we can do is tell it to have more renders. And I'm going to provide, be careful with that. Do not save yet. I have to warn you, if you have a bad computer, you're gonna have a long freeze when you save that, when you reload the page. So maybe test a lower, if you don't trust your computer, maybe test a lower value like 200. You will get a different result, but be careful. I'm gonna put 1000. Okay, it's a lot. I'm gonna save. I had the freeze already. I'm gonna reload to have another freeze, and I get this. Check that shadow. So check on your computer because maybe the video compression is not great. So check. It's just beautiful. I love that shadow. Check that. The performances are just fine. They are so good. The performances. There's a catch, but right now it's all good. It's super nice. Super nice. The cube is a bit weird. And it seems that it's not animated, but the first problem we had is that when we reload the page, there is a freeze. See that? I almost like maybe 1 second of freeze. That's too much. And if I put more there, 2000, I reload the page and a longer freeze. Wow, it's bad. What's happening? The shadow looks smooth, but 3GS had to do those 1000 renders on the first frame. Yep, you just ask 3GS to render. I think there is 8 lights casting shadows and moving. So 8, maybe there is something like 8,000 renders, shadow map renders being done. I might be wrong about the calculation, but it's a lot of renders on the first frame, which is why we get that freeze. All right. So let me show you the shadow again. You need to reload every time you change some values. Ooh, so that might be an issue, especially like for this iOS. I hate iOS for that. So the iPhone, when the first frame takes too long on iOS will reload the page. So I hope this is gonna be fixed at some point. Maybe what I'm saying that this has been fixed, but it has been like that for years, and it's going to reload the page. So it's going to freeze again. So it's going to reload the page. So it's going to freeze again because iOS thinks that the problem will solve itself because the frame is too long. But it's fine to have a long frame at the beginning. But your website won't work on iOS because of that. I'm a bit pissed because I had so many client projects that went wrong because of that. Classic issue with iOS. Anyway, I can't help myself to trash talk Apple and iOS. Sorry. We can fix that. I have good news. We are going to ask the accumulative shadow to spread the renders in time across the frames. And to do that, we are going to add this temporal attribute. You will have to be patient. Give it a reload. So first of all, there is no freeze. I do it again. I reload the page. No freeze. Nice. And now wait a bit and check that. I know there's a bug here. If you see some weird lines, don't worry, we are going to fix that. But check the shadows that are being accumulated and we can see it. But it took time. Actually, you can calculate how long it took. My computer is running at 60 frames per second. So I'm going to do 1000 divided by 60. 1000, I said, divided by 60. And we get 16 seconds. Yeah, it took 16 seconds to get the final shadow because we have that much frames to render. And there will be only one frame render on each frame because it's temporal. All right. So that's kind of the price, but we also have this this artifact issue. We're going to fix that. So yeah, a weird shape is being drawn on the shadow. So try to move the camera like this and see there is some shapes happening here, some grid. And as you can see, it's because of the helper. All right. The helper is being drawn in the whole process of the accumulative shadow, and it's messing up with our shadows. So what we can do to fix that is remove the helper, just like that. All right, the helper is gone and the shadow will look better. Easy fix. Where is my shadow? Oh yeah, I need to give it a reload, as always. So first fix, we can reduce the amount to, let's say, 100. All right, let's test with 100 shadows. So as you can see, the shadow when visible in less than 2 seconds. If you have a higher frame rate, it's going to be faster. All right, but for me, I have a 60 frame per second computer and a screen, so I need less than 2 seconds to render those frames. All right, it's kind of fixed right now. But the shadow doesn't seem to move according to the cube. Check that cube here. Like if you watch, I mean, the back is okay because the cube is not moving that much, but nothing is moving below it. It's a bit weird. And yeah, that's the case. It's because those 100 shadows are being rendered on the 100 first frames and then it stops. Which might be good enough for you. Again, if your scene is static, that's great. So we run the first frame, we take a bit longer. So maybe the performances will be a bit, the frame rate will be a bit slower on the first 100 frame. But at the end, you get a beautiful baked shadow on the floor. Why not? But if your scene, your objects are moving, we need to fix that. So what we are going to do is, what are we going to do? Ah yeah, first we want to see that issue more clearly. We're going to move the cube left and right. You can try that. Don't watch the slides there and try to move the cube. I want the cube here to move left and right, left and right. Try to do that, pause the video, just to practice a little if you want. Otherwise, let's do it together. So first we're going to use frame. We already have use frame because we are making the cube rotate. And in there, we're going to move it left and right using a sin, all right, sinus. So first we need the time, why not? So state clock elapsed time. I'm going to do it quite fast because we already did that in previous lesson. Now we get the elapsed time, all right? 0, 1, 2, 3, so it's the time that is passing. Great. Next, we are going to move our cube. So it's going to be cube current position x equal. I'm going to use 2 as the base so that the cube initial position is there. So I'm going to add 2 plus math scene, and I use the time. Right? I'm not explaining in detail. You probably already know about that. And now the cube is doing like that. All right, it's using a sinus, using the time that is passing. So as you can see, the shadow started to be rendered. Let me show you again. The shadow is being rendered on the first frame, so the first 2 seconds, and it's moving and then it stops. Yeah, that's the issue. It's being rendered only on the first 100 seconds, so we want the shadow to keep following the cube so that it looks better. We can do that by adding 2 frames. Okay, frames, where is it? It's over there. 2 frames, we are going to set it to infinity. All right, this is a JavaScript kind of number. You can put infinity here, you get infinity. This is a number. It's like the highest possible number. We have some fun stuff to do with this one that kind of mess with JavaScript concepts, but I'm not going to explain that. We don't care about that. Anyway, the frames are now infinite. What does that mean exactly? Let's say I'm going to reload and we get this. It seems to be working, so the shadow seems to follow. There is a small delay, but it seems to work, to animate with the cube. But that shadow doesn't look really good. It looks a bit like stop motion, you know, when you animate small characters and take a picture and animate small characters. But that's not what we want. We want our shadow, our good-looking shadow back. And we can do that because right now there is only 20 renders that are being accumulated. And we can add more renders by adding the blend attributes. So it's going to use more renders. By default, it's 20. It looks bad. We're going to add 100 and check that. I'm going to reload and we have 100. Oops, sorry. We have 100 shadows that are being accumulated right here. So it looks nice. And this one is being animated. But you can see that there is a delay. Okay? Because there is 100 shadow frame delay for the last shadow against the first shadow, and it's accumulating it. So that's kind of the price when you use it. The accumulative shadow is not great for animated objects. If it moves slowly, it's fine. If it moves a lot, you're going to have this delay or lost the shadow because the cube is already gone. So it takes its bite on performances too. As you can see, this is quite bad. On your computer, maybe you don't have a very good computer, the frame rate is going to go down. So right now it's fine. I can go up to 16 milliseconds and it should be still fine. It's kind of the limit since I'm at 60 FPS. Yeah, that's the price. So for a static scene, use the accumulative shadow. For slow moving scenes, use the accumulative shadow, but be careful with that. The performances and stuff. All right, the higher the blend, the less chance you have to see the shadow on fast moving objects. Well, a lot of tweaks. As I said earlier, add leva, add all those parameters to leva if you want to find better tweaks. You can probably find better tweaks than the one I put. All right, nice. Comment or remove. Yeah, we're going to, before switching to the rest, we're going to remove some of those changes we did. We're going to remove the cube animation, because we don't need it anymore. So in the use frame, the cube animation, so left, right animation, you can comment it. You can keep the rotation on the cube, okay? Then we're going to remove, let me check. We can keep this one. Yeah, we can put back the helper. It's up to you. Anyway, we're going to remove the accumulative shadows right now, because we have to see a new one, which is the contact shadow. I really like this one. It looks super good. It's not very realistic, but it looks so good. You will see. The contact shadow. Contact shadows doesn't rely on the default shadow system of 3GS. Yeah, that's a new shadow that doesn't care about your 3GS shadows. So first, we're going to deactivate the shadow on the canvas. We can do that by removing it, commenting it, or just put it to false. It's up to you. I'm going to put it to false. Maybe at some point we are going to put it back. And as you can see, no more shadows. So the accumulative shadows doesn't work anymore. We can also comment it so that it's not being used anymore. Be careful, the GSX is going to be a bit messy at the end because we are testing a bunch of stuff. So try to follow me on the various changes I do. And I commented the accumulative shadow. Next, contact shadows work without a light and only on a plane. Yeah, a bit weird. The contact shadow doesn't rely on light. I mean, it creates shadows, but it will just create shadows by checking what's above it because it's a plane. So again, it works nice for the floor. So you have to make sure that you only use it like on a plane. Well, you can use it on a wall, but usually we use the contact shadow on the floor, as you will see. So the contact shadow will render the whole scene, so a bit like the lights are doing, but with the camera taking place of the floor. In our case, we are going to put the contact shadow as a plane on the floor, and it will put itself like that and render from below. A bit weird, so it's kind of the opposite. Instead of rendering from the light and putting the shadow on the floor, we're going to render, contact shadow is going to render from the floor. It will then blur the shadow map to make it look better. It's going to be a simple blur, like just blur the shadow. It doesn't take care about the distance of the object, it just blurs it. Blurring is bad for performances, but you will see that the performances with contact shadows are really okay. So first, let's go. So a lot of promises. Let's see what we get with that. So contact shadows with an S from React 3 Dre. And next we are going to add it. So where should we add it? So it can be anywhere. You can put it anywhere in the scene. I'm going to add it after the accumulative shadow. Why not? So contact shadows with an S, and we can auto close it like that. We reload the page and we can already see something. So that's a bit weird because we get the helper. Again, we should have removed it, but I'm going to keep it because it's in the text version. But yeah, it's there. So it's not at the right place. Again, it's at the center of the scene, and we need to lower it right above the floor like we did with the accumulative shadow. And we can do that with the position attribute, position, and send an array of 0, minus 0.99, so that it's right above the floor, and 0. We don't want to move it on the X and the Z. And we get something like that. Not bad. Not bad, but far from perfect. We need to work on that. So first we can change the scale. Again, the default scale is just perfect, but if you want to reduce it or increase it, you can. So if we put, I don't know, like 2, we get a very small shadow. It's way too small. Let me put, 5. 5 is like this. It's not enough. And if we put 10, it fits perfectly our floor. All right, so it's up to you. Make sure that it fits your scene. Next, we can change the resolution. The default resolution is actually pretty good. Remember that some renders will be done on each frame, so we can change the resolution to, I don't know, something smaller, like 128. And right now it's a bit weird, especially on animating objects, because it's super small. This small resolution will be blurred. So sometimes a very small resolution can still work, but in our case, maybe it's better to add a bit more, like 512. Which is okay, which should be good for performances. By the way, check the performances. Right now it seems pretty okay. Next, we can choose how far the shadow will render objects above with the far attribute. So if you have some flying birds on top of it and you want to see their shadows on the floor, you will need to increase the far, but in our case we don't need much. We're going to put 5. This can try to find a nice value so that the precision of the shadow is good. If you put like, I don't know, 10,000, you might get some weird bugs, so try to find something that fits your scene. So I will put 5. Next, we're going to add a bunch of parameters, and this time we're going to add them to Leva. All right, let's go. Maybe we say Leva. I just realized. I'm gonna keep calling it Leva. Now would be a good time to practice on your own. Yeah, by the way, I want you to add 3 parameters that we haven't had the attributes yet. Those are going to be color, opacity, and blur. And you're going to add those to Leva. I'll let you discover how to add the color, the opacity, the blur, if you want to do it. If you just want to follow the lesson, just follow me. But if you want to practice a little on your own, try to do that, pause the video, and now let's do it together. So first we're going to import Leva. We are forcing the version to prevent surprises, as always. If you get some warnings, you can ignore them. Yeah, by the way, Leva is not added yet to the project. So npm install Leva at 0.9. All right, I want this very specific version. If you use another version, you might get some bugs. All right, cool. It's installing. Then you can restart the server if you stop it. For me, it was in the different terminal. You can use that button to get multiple terminals. So it's still running, and we should have access to it. So let's go. In the experience, we are going to import Leva. So let's go. we're going to use controls from Leva, like the previous lessons. Leva, like this, compiling. Okay, it's working. Nice. Next, we can close the console, the terminal. We are going to add it. Yeah, I think I will add it right here before the return. Sometimes it's better to add it at the beginning, makes a bit more sense, or it doesn't really matter. So I'm going to put it here. I know that I'm going to retrieve those variables. So it's going to be color, opacity, and blur from the use control. So I'm destructuring them like we do in the previous lessons. And I'm going to do use controls. So I'm going to call use controls. And first I'm going to create a folder in Leva. So the first parameter is going to be a string. I'm going to call it contact shadows. And then I'm providing the tweaks. I like to put some line breaks like here and here, like that. It's up to you, you do whatever you want. But I'm going to follow the lessons to make sure that we have exactly the same thing and put it there and there, like this. So that's an object. So first parameter, the name of the folder that will be created. And second parameter is the object with the various tweaks. And first we want the color. So I'm going to do the same order as here, although it's not that important. And I'm going to create a black color like this. There is 6 zeros. Yeah, 6 zeros. To start with, obviously we're going to tweak it. That's the whole point of adding Leva. For the opacity, I want, a range. Is it range? A little slider. So I'm going to put a default value to, I don't know, 0.5. Put any value you like, and it's going to go from 0, so mean 0, to max 1. Great. And the last one is going to be the blur. If you do it on your own, maybe just focus on one tweak at a time. It's just that I did it already, so I put everything at once, and I have the code right below, so it's easier. For the blur, we go from 0 to 10. All right, and if you want to go above it, you can try values above it. I save the page. You can't ignore this error as we've seen in the previous lesson, in the debug lesson. It's okay, it doesn't matter. This thing is about Leva only. It won't impact your experience. And we can play with those, but we are not using them in the attributes yet. So we need to associate those variables that we destructure from the use controls with our contact shadow. First one is going to be the color. Second one is going to be, I'm going to be lazy and duplicate them. So second one is going to be opacity, and third one is going to be blur. All right, I hope I didn't go too fast on this one. And check that out. Nice, what do we get? We can play with it and, I don't know, change the color to something red, why not? Change the opacity, okay, nice. Change the blur and do whatever we want. And that's so cool, so easy to tweak. As you can see, it's a general blur, but it looks super good. And check the performances. They are just fine. I think there is more parameters, by the way, but we will only focus on some parameters. Go check the documentation on Dre, and you will find maybe more parameters. And for the shadows, when it's a green floor, I like to make kind of bluish shadows. So maybe not that blue, something like that. Maybe we can move it there. Yeah, something like that. Let me see, reduce the opacity quite a lot. Something like that. Yeah, nice, I like this one. A bit blurry like that. Yeah, I like this one. You can tweak it the way you want. You can also, maybe you change the color of the floor, so you need a shadow that match the color on the floor. It's up to you. And I'm going to cheat and use those parameters here so that I have exactly what I had planned when I wrote the lesson. So it's going to be 1D8F75. For the opacity, it's going to be 0.4. And for the blur, it's going to be 2.8. Let me see what we get. Yeah, this one is looking good. Looks exactly what we had before. That's just fine. We can bake the shadow. Yeah, by the way, we can bake the shadow again. So the performances are really good. So if the object is moving, rotating, it will be perfect. Don't worry, unless you really have a complex scene or huge shadow map with a very high resolution. And in that case, you might want to bake the shadow. So only render it once. If your scene is static, you might want to bake it. So where is my contact shadow? Is there. To bake it, you're going to do frames equal 1, so that it's only render on the first frame. I reload the page, and as you can see, the one below is still rotating. Oh, sorry, frames with an S. I was wondering what I did wrong. And now the shadow is not rotating, so you can't see much of it, but if you reduce the blur, see that? The shadow is not rotating. So if the scene is baked, you can do that. If the scene is static, you can do that. All right, contact shadows looks very good, but it has limitations that we already kind of talk about. First, the shadow always comes from the front of the plane. All right, so it's everything that is above it that the shadow will cast on it. If the lights come from the side, which is the case for us, it comes from here, you can't have the shadows there. So next issue is that it's not physically accurate, but it's kind of, it will handle, like if the object is far, the blur will be the same, but the opacity will be reduced. So it looks realistic enough. Honestly, people don't mind too much about that, but it's not physically accurate. It blurs the shadows regardless of the distance from the object. That's what I just said right now. So it's the same blur regardless of the distance of the object, but usually we don't see much of a difference. And it pulls quite a lot on the performances, but it's fine unless you have a huge scene and you're rendering on each frame, which is not the case for us because I put the frames to 1. It will take its bite on the frame rate. Next in the list, we are done with the shadows. Yay! So as you can see, there is a bunch of shadows. Use the one that you prefer depending on your scene, depending on your context, if it's static or not, if objects are moving a lot, how realistic you want it, and the performances. But let's put the shadows aside and talk about the sky. And we already know the sky in 3GS. There is a class to do that, but we are going to see that it's very easy to implement it in React Free Fiber. All we need to do is use the sky helper. So let's go. I'm going to import the sky from Dre. So sky like that. And I'm going to add it to the experience. And I'm going to add it, I don't know, maybe after after the ambient light. Let's go. It doesn't matter. I'm just a bit picky. And I'm going to auto close it and check that. We have the sky. So don't mind the warning. Okay, it's about leva. We don't care about that. There is the sky, so the sun seems to be there because it's brighter. And if you rotate around, well, it's working. And we're going to have some fun on the sky. It's the opportunity to practice some leva stuff and etc. So the sky. This class is physically based, and tries to reproduce a realistic sky according to various parameters. So those are very scientific parameters. I know nothing about those. I wrote some article about that. I remember nothing about those articles. So it's the Mi coefficient, the Mi directional G, the ray lay. What's a lay? I don't know. The turbidity, obviously the turbidity. Everybody knows about turbidity. I always talk about turbidity. We are not going to cover those, okay? We are just going to make the sun move. It's already enough. It will be a bit boring to set all the parameters, but if you want to do it, pause the video and have fun doing it. So let's go. We are going to add the sun position to the leva, just to have some fun with leva. We are going to go there where we already have the contact shadows, and we're going to create a new one. So I'm going to destructure it because we are going to get the sun position. We know that already. I'm going to call use controls like that. I'm going to put a name for the folder, just like we had contact shadows. We're going to have sky, very easy one. And then we're going to send an object, and it's going to be a tweak named sun position. And we want 3 values. So it's going to be value 1, 2, 3, just like that. Let me see what we get. Yeah, we get something like that. When you hover the label of each one of those parameters, you can play with it. All right. Cool. Then we're going to use that value on the sky, and it's super easy. So you scroll down on it, yeah, sun position, and we send the sun position variable. Let's see what we get. So the sun is over there. If I play with the Y, I can lower the sun. I can move it up. So if it's below 0, well, it's the night. If above 1, it's the day. I can play on the X. I can play on the Z. It's working great, but be careful. I did something the way we did it is not the usual way. The sun is super far away. Setting a position like 1, 2, 3 on the X and Y doesn't really make sense. It will keep the sun super far away in the case of the sky. All right, those are just like mathematical coordinates. it's a vector 3 of mathematical coordinates. You won't see the sun like inside between the sphere and the cube. But it's hard to set the right sun position using that. Like if you move on the X, you want it to go in front of it, it's a bit weird. Usually we use spherical coordinates, all right? I didn't do it because things are getting a bit harder, but I just want to warn you that when you want to position a sun around a scene and get the right coordinates, usually use spherical coordinates. And spherical is a mathematic class in 3ds where you control the radius. You don't care about the radius, but you can also control the phi and theta. Phi is the polar angle. I always get those wrong. I think the phi is the one doing that on a sphere. Imagine a sphere. Phi is from like the North Pole to the South Pole, and the theta is like this. All right, and you create those parameters like in leva, so phi and theta. You keep the radius at 1, and then you convert it to a vector 3 because the vector 3 has a set from spherical method. All right, I will stop there. It's just in the case you really want to implement it, you should use spherical coordinates. And if you are trouble doing it, just join the Discord server, ask for help. So the 3ds Journey Discord server, ask for help, and we are going to help you. Yeah, by the way, there is a small issue. Check that. If we move the sun, so it's working, but as you can see, the shadows are not following it. It's kind of a small bug. We can fix that quite easily. The sky, the sun in the sky is not the same as the directional light. And we can fix that super easily by using the sun position on the directional light. So right here. So I copy the sun position variable and I passed it right here on the position of the directional light. It's just a quick feature, like check that. If I do that and I move the sun, see, the sun in the sky is changing and the sun, the directional light is changing too. That's just a cool feature. If you want to set your scene, everything should match the same parameters. It makes more sense and it makes the composition much easier. Nice, we are done with the sky. Next element is environment map. Quite a big session, but quite a cool session. And we see that we have so many helpers that are really cool. So in previous lessons, we implemented an environment map by using a 6 textures set. So it was a cube map, you know, with the, it's like a render on the left, a render on the right, a render forward, a render backward, a render up, a render down. And this is used to compose the environment map. That's one way of doing it. But there are other ways which are actually better, less for performances, but better in general for the way it looks and lighting, you will see. It's to use like 360 photos, and those are called HDRI textures, and we're going to implement those. First, we're going to do the classic cube map texture, and then we're going to see those textures, and I'm going to talk a bit more about those right after. So obviously, Dre made the process easier with the environment helper. So let's go. We're going to use the environment map to eliminate the scene. To prevent conflicts, we're going to remove the current light and also the sky. The environment map can be used to light the scene. So we're going to get rid of some stuff here. We're going to comment the directional light, like this. We're going to comment the ambient light, like that. And next, I think we can remove the sky too. Let me check. Yeah, we have to remove the sky too. Like this. So it was a cool sky, but we have cooler stuff to see. So the scene is all black and we can see the ivory background here, but we are going to change those right now. So we need to import it, environment, like that. It's okay to import those. Those are just for testing so that if you uncomment the instance, you can get them back. So now we add the environment to the import, singular, and we are going to start with the cube texture. By the way, in the folder, there are some cube texture. If you check in the public folder, I've put some environment textures, as you can see here. Let me show you. Those are cube map textures like we used to do in the previous lessons. Okay, so I put the kind of the same one. Let's test them. You can we're going to test only one, but you can test the other one. And there is a HDR one too that we will see later. Okay, so they are in public environment maps with an S, and the cube maps are in 0, 1, 2, 3 folder, and later we're going to use this one too. later. Okay, we get back to our code. And we're going to add the environment to the JSX. So let's go. I'm going to add it at the beginning, why not? Environment like this. I think we can auto close it for now. Later we're going to change that, but for now let's do that. And we're going to provide a files attribute. And to that files attribute, we're going to provide an array because we are starting with the cube map and its multiple textures. And we're going to set, so let's set the first one. So it's going to be environment. It's hard to write. Maps. I'm going to use the 2. Why not? PX JPEG. Be careful with the order. So it's a positive X, PX. I like to name the textures like this. I'm going to duplicate it and I'm going to have negative X. You must have the exact same order. So positive Y, negative Y, positive Z, negative Z. Quite long to set, but we see that it should work. And we get something nice. It's already working. Great. We can change the intensity because right now the only thing that is creating light in our scene, that is lighting our scene, is the environment map. Remember that we removed the directional light and the ambient light. So we need the environment map to be stronger. And we can do that with the env map intensity, which is by default 1. We have to improve this one. What we are going to do it, because this one has to be set on each mesh. So where my mesh is, right here, we need to set the env map intensity on each mesh. So it's a bit messy. If we want to tweak it, it takes quite some time. So what we're going to do is add it to Leva. So let's go. We're going to add a new use control. So const env map intensity equal use control. So it's the usual thing. The old one are not being used anymore. I mean, the shadow right now is being used, but this one is not being used. Let's just keep it. So environment maps, that's the name of the folder. Then we provide an object, and in there I'm going to cheat a little and copy it because it's super hard to write. It's the env map intensity. Did I write it the same way? Yes. So value 1, min we put 0, and max we put 12, should be more than enough. And if you want a higher value, you can test with a higher value. All right, we now have this tweak, but it's not being used inside our JSX. So we need to go to our meshes, those meshes that for me are at the end of the thing. And yeah, by the way, I said a mistake. It's not on the mesh, it's on the material. My bad. And we're going to set env map intensity. So the attribute is exactly the same name. It's going to be env map intensity. I'm going to test on the first one and check that it's working. And I'm going to use the same value. So let's be lazy and copy and paste it on this material and on this material right here. And now we can control the general env map intensity. All right, cool. If you want the same value as me, you can put 3.5. So let's see, env map intensity. Yeah, 3.5. So that every time we reload, we get this decent intensity. So it's maybe a bit low, but don't worry, we're going to change the environment map later anyway. So just find a bigger value. It should be more than enough for now. We are going to talk about background, but background with the environment map, not just a uniform color. I'm going to talk about, we are in the environment section. I'm going to talk about how to get the background for the environment. I mean, our environment into the background. And it's super easy. Check that. You can just do background like this. You add the background attribute and check that out. We have the background. Nice. So easy. So easy. And that's all for the background. Next, I told you earlier that cube maps are okay, but HDRI are even better. And we already have one in the folder that we are going to use. So it's like 360 photos, so all around. And it's usually high dynamic range. I mean, if it's HDR, it's high dynamic range, meaning that you have more data in those. So usually it's also like bigger files. You will have to load quite heavy files. And it's cool because it makes sense with lights. We are using the environment map to light the scene, but with the images we have here, those are limited values. It's just colors. If you use HDR textures, it's more than just color. It's really like accurate light value. And the sun will be brighter, as an example. much brighter than just white. It's not just white. The values go much above 1. Much above white, I mean, sorry. So yeah, there is already the file in the folder that I told you about. So we are going to load that file, and it's super easy. We didn't have to say anything special with the environment map when we wanted the texture. We just had to put an array inside the file's attributes. And to load a HDR file, we just need to put one path, right? Instead of the array, we just put one string value, which is the path to that environment map. So it's going to be environment maps / the sky. I didn't change the name of it. Is on fire. Don't get too excited. It's kind of a normal HDR. You're not going to see some apocalyptic background. So we switched. We had the HDR extension, and yeah, it seems that I did it right. And as you can see, we get a nice looking environment map. Kind of the same results, but actually see the light here. It's kind of a darker, no, it's got the brightness of the environment map is very similar to what we had before, but since it's light value, more accurate light values with the values that can go beyond 1, so it's like if it's white there, actually it might be even more, we get a much better lighting on the scene. So that's one of the reasons why HDR are better for the scene, to put to illuminate the scene. By the way, if you're looking for cool HDR textures, you can go on Polyhaven that we already saw in previous lessons. So Polyhaven has HDR texture, also textures, also models and stuff, but we are focusing on those ones. And you can download them. So I don't know if you want this one, you can just click on it. And you will have to choose which file you want to download exactly. You better use HDR and use the smallest possible resolution, all right? This means that if you look at this image in the background, it will look bad. So the smaller, the worse it gets, but it's much better for performances. So you have to try. We're going to talk a bit more about the resolution of the environment map after. Anyway, we're going to use this one, which is already pretty good. By the way, they are under CC0 license, meaning that you can do almost anything. It's a public domain, so you can do almost anything you want with it. Let's talk about the presets. Yeah, this one is really cool. Even better than having to download the file, Drake created presets that we will take the files directly from Polyhaven. So we don't even have to download the file, and we can use those ones. So I put the link, as always, check the link tab. You can use those presets that will load the corresponding environment maps. And it's just various realistic environment maps. So if you want to use, let's say, the sunset, this one, you comment or remove the files one, like this. You put preset equal, and you put any of the names you want to test there. So sunset, check that. And we have it running. Nice, easy. So I think it's the same, by the way. No, it's not exactly the same. Maybe it's a different one. Anyway, it's working, and you can try other ones. Like, I don't know, like the night one, night, and we get something like that. So much darker, but it's working just by changing the preset. So if you want a specific one, you can still download it and use it. But if you want some, you're good with the presets, use the presets. So let's talk about custom environment, and this one is so cool, like so handy. We like this one. Okay, it's good, but something bothered me. I wanted to have, I don't know, like a red cube here that illuminates this part of my object with red. So the rest is just fine, but I really want to have some kind of red objects that where the light bounces and have some red illumination on those objects from that red thing. Should I try to recreate the environment map in Blender and do render, and it's going to be super complex, and it's going to take time? No, there are very easy solutions. We're going to add a big red rectangle here in the environment map, and you will see that it will work just like that, just by adding a mesh inside the environment map. So let's go, let's try that. We're going to position a mesh inside the environment map, and you will see that it will be part of the environment map. But first, what I always recommend is to put it outside of the environment so that we can make sure that we create it properly. So we're going to create a mesh. It's going to be a plane geometry. So something like that. We can auto close it, and we are going to add a mesh basic material because we just want something red that we create some lighting, some red lighting, and we put it like that. All right, let's see what we get. Okay, it seems to be okay, and we're going to move it away like on this part here and make it bigger. So let's go. We can move it on the position. It's going to be position Z. And we can put maybe -5. Yeah. Let's see. Okay, it moved on the right way. And then a scale of, let's say, 10 so that it's much bigger. So this is our mesh. Now we put it inside the environment. So we have to remove the auto closing and close it ourselves so that we can put something in it. And check that without doing anything else. It's now part, so you have to give it a reload. It's now part of the environment. So it looks huge, but it's working. You can tweak the environment just by playing with by adding meshes inside of it. And check the light here. It's more red because we created a red object here, and the environment map is illuminating the whole scene. We don't have any more lights in the scene, and it's working, so you can tweak it really easily. Next. Yes, we did that already. Oh, and if you want, you can remove the preset if you want to check without it. And as you can see, all we have is that red plane illuminating everything. By the way, the default background is white. I mean, the background of the environment is black, but we can see white because it's transparent, so it's a bit weird. And I think we can change that. Yeah, we can change that just the way we did previously. When we added a color to the scene, we want to add a color to the scene of the environment. And to do that, we can just add a color like this, color, args. We're going to provide, I don't know, like a blue, so it has to be in an array like this. And don't forget that you also need to attach it to the background property of the scene. And it's going to be the parent scene, which is going to be the environment map scene, not our current scene. That's just working. So you do attach to background property and check that. Now it's blue. And if you want it to be black, you can do black. Sorry, no, this one black like this. Now it matches. Nice. So easy. So you can just create environments like this. And they are being rendered, I think, only once on the first frame, so the performances, as you can see, are really good. Yeah, we can change it to black. I'm going to use the exact same code as I prepared, so it's going to be an hexadecimal one. Using meshes to illuminate our scene sounds like a limited solution, since light shouldn't be limited to the color spectrum. Like if you want to add a light, a red light on the left, this is the higher intensity you can get from that technique. Well, actually, I have good news. It's not very realistic because in real life, we should be able to make the red plane brighter and brighter. Like if we want to create a red light and then we want to increase the intensity and increase the intensity and increase the intensity, sorry, it seems that we are blocked right now. We are limited. But it should be working. And to our eyes, if you add a brighter color, it should become more white and whiter and whiter until everything looks white because it's too flashy. Like if you look at the sun, maybe the sun is not white, but if you look at it, it seems white because it's too intense. Or like, you know, in forging, when you heat metal, like the blade, if you hit it more, it's going to be whiter and whiter and whiter. And we want this effect. But currently, by setting a mesh like that, all we can get is kind of a low red light. Don't worry, we can fix that. But first, we can't use a literal value like that. If you put red, well, this has a limited range. It's going to be RGB, a high R, let's say to 1. The G is going to be at 0, so the green is going to be at 0, and the B is going to be at 0 too. So it's limited. So we need to find a way to send something else. And the good news is that since this we create a color, an instance of 3GS color, we can provide colors in a different way. We can use hexadecimal, all right, this one is limited to, but we can also provide an array. So to that color, instead of a literal color or an hexadecimal color that are limited, we're going to provide an array, and we're going to provide the same for now, so 1, 0, 0. what do we get? The exact same thing. But since we are providing our own values to create the color, so red, green, blue, we can go beyond 1. Let's say 2, and check that. It looks brighter, so it tends to go to the whites, and the scene is more illuminated like that. And can we go even above? Let's go crazy and put, I don't know, 10, and check that. It's like a huge sun, like a red sun, and it's so bright that everything tends to go white. And you can put, I don't know, like 100 if you want. And now it's super white, and it's working like everywhere, and everything is being shined by this huge plane with super intense red lighting, and it's working. That's great, but there is actually a helper to do that, because right now we are kind of tweaking the normal behavior. We are putting a color that goes beyond 1. It's a bit weird. You can do that, but it's a bit weird. But there is a helper for that named light former. The purpose of light former is just that, and you will see that we can go even beyond, do even more things. So we're going to comment this one. If you want to use meshes to do it, you can totally do it. There is no issue with that. But we are going to use the light former instead. So it's all black because there is no light in the scene. So let's import the light former from Dray. So in this one, we're going to add light former, and we're going to add it inside the environment. So I can put it, I don't know, like there. I'm going to add the light former. I'm going to move it at the exact same position. So it was Z, I think, -5. Yeah, that's it. -5, and put a scale of 10. Let's test. I don't know what we are going to see. Let's just see what we get. Like that. Okay, it's back. By default, it's a white, so it doesn't look totally white because of the tone mapping, but it's kind of the idea. And on that light former, we have access to more attributes that make more sense than having to tweak the mesh basic and providing weird values that go beyond 1. So we can still put a literal value. So that's great. If you want red light, you put red. Okay, we get back the red, but now you can push the intensity above 1 by playing with the intensity attributes. And now we get the same result. It's the same result, but it makes more sense. It's a light former that will create some shape to light your scene, and you can just play with the intensity. And if you want, you can use any color you want. Like if you want a cyan, you can have a cyan like this, but it's super strong, so it looks more white. But see, now it makes more sense. All right, cool. Let's put back the red, I think. And by the way, the default one is a rectangle, just like the plane that we created, but the light format can also support more things, like with the form attributes. You can put, as an example, not right, it's ring, like this. And see, we get a ring. So the result is kind of the same on the illumination, but if you use it on a scene that has reflection, it's going to look much better. We're not going to do it. You can do it. If you want, you can pause the video and add some reflection you reduce the roughness on those objects, and you will see that the ring will reflect on those objects. But instead of doing that, I'm going to show you an example, which is a very good example. It's this one. As always, the links are in the links tab. Wait a moment. Yeah, see that? The reflections we see on the car are using the light form, and they are being animated, and it looks so good, so realistic. And yes, by the way, we can animate them, but we are not going to do it. Nice. So I'm going to put it back as it was, like that. And back to our experience, which is not that good looking, but it's a start. Okay, let's put back the preset. I want to show you something. Preset, I'm going to put the sunset again. So sunset, like this, and check that. The light former, and the environment map are being combined together. Just like we added the plane to the environment map, we can add the light former to the environment map, and it's working. See that? It's brighter here because there is a huge ring light all around. Nice. The whole environment map had to be rendered. Yeah, by the way, since we need to render something, there is a render happening. So it's not the direct HDR texture that is used. There is a new render happening with the environment map texture and the light former added to it, meaning that we can also control like the resolution, and you can lower the resolution like a lot. Let's put 32, which is quite small, and check that. It's all blurry, but the performances are much better. And it's kind of important because the environment map, it's quite bad for performances. You can put very small resolution, especially if you don't see it. Like if I remove the background, I'm using the environment map only to eliminate the scene, put the smallest possible resolution, and performances are going to be better, and the result will be just the same. This one is super small, and as you can see, it looks just fine. It's a bit too bright, obviously, because it's quite intense. The light former is quite intense, but you can really lower the resolution if you don't see it in the background. Good for performances. All right, we're going to comment everything in this one, like this one and this one. You can add back the background so that we can see it. By the way, the resolution here is not being used, okay? Because there is only a texture, and Rec 3 Fiber won't re-render the environment map if there is no reason to re-render it. And since there is nothing in it, there is no reason to re-render it. Okay, nice. We're almost done with the lesson. Quite a big lesson, but it's just a bunch of cool features that you can use or not. You do whatever you want. Remove or comment the resolution. Yeah, because it's not being used. Let's move forward, and we're going to oh, this one is so cool. The ground. It has been added quite recently, a few months ago, and it's super cool, you will see. When you are using an environment map as a background, which we are doing right now, we have the feeling that objects are floating because the image is infinitely far away. So check that. See, I'm moving and it feels like the objects are floating, which makes sense. It's okay, the environment map is in the background, but can we fix that? Good news, yes, we can fix that. By adding a ground attribute, which we are going to do right now, the projection of the environment map will make it look as if the floor underneath the object is near. It's going to work. You will see, just add it and you will understand what's happening. First, you need to remove the background, okay? You can't have both. In the end, you will see it in the back, so you get the same result. But, I mean, you see it in the back. And then you provide a ground and you inject an object and you provide the parameters. And we're going to talk about those parameters, but for now, you should put the same parameters as me. And we put a radius of 28, so the 8 at 7, the radius at 28, and let's put a scale at 100. We are going to add those to Leva right after. And check that out. I'm going to zoom out a little, and we get something like that. It's not perfect yet, but see, the floor seems to be on the floor, although there is a weird offset. It's working. Let's try to fix that weird offset. That ground is considered to be at the 0 elevation of the scene, meaning if I move there, see, the camera is currently at 0, and the ground is at this exact same position at the center of the scene, which is why it doesn't work perfectly, because our objects are going below the floor. So we're going to fix that by moving those objects up. So let's go. This is for the 3 meshes we have here. So we're going to put, I don't know, I think it's, yeah, position Y to 1. So let's go. Position Y equal 1. We can do the same for the cube. So it's this one here. So up, they moved up. And we can do the same for the floor. So it's going to be 0. Yeah, we want the floor to be at 0. And actually, we already have position Y. So we can just put 0 here. Okay, we already have this attribute. And we save. And now it looks much better. You don't have to reload, but you can give it a reload if you want. Much better. It fits the background. It matches the background. By the way, we don't really care about the floor anymore, so we can just remove or comment this one here. And check that. It's working. Nice. Oh, also, the shadow, let me see the shadow. Yeah, I forgot to move the shadow in the slides. So the contact shadow, we can keep the contact shadow. So we can move it up by setting a 0 here, now that we remove the floor. And I'm going to keep the green shadow, but you can change it. Like if you want a better looking shadow, maybe you can put something like that. Yeah, it matches a bit more. Let's do it. I'm going to change it to this value. So 4B2709, so that it's not blue, because the shadow were blue for the green floor. Now there is no more green floor. And check that. It looks so good, so realistic. So yeah, obviously you have some kind of distortion happening here, It's kind of the price, but we can tweak the parameters so that it looks better, which we are going to do right now. So let's go. We're going to add new controls for the lever. We're going to have the env map intensity. Oh wait, actually we're going to add it to the environment map here. So this one, it's not a new control, so we are going to use this one since it's also an environment map. And we are going to add the env map height, env map radius, and env map scale. So the height, radius, and scale are the parameters of the ground. So let's go, let's do that. So env map height, you can just put height if you want, but I'm going to put the whole name. To 7, min to 0, max to 100. I'm doing it with you. The radius, we're going to put 28, 10, and quite a high value here. You see that those parameters are super hard to understand. I mean, I'm having trouble understanding those parameters. And when I don't understand those parameters, I just add them to the debug UI, like that GUI or lever, whatever, and I tweak them until they look good. And that does the trick. And then we have to retrieve them in the destructor of the use controls. So env map height, env map radius, and env map scale. Right? Maybe I went a bit fast, so pause the video. Then we are going to use those. So env map height, env map radius, and env map scale on the ground, which is right here. Actually, we can have them both on screen. Oh, that's not a space. Yeah. So env map height, we put it there. Env map radius, we put it there. And env map scale, we put it there. So currently I think we have kind of the same value, or maybe the radius changed. And now check that. We have those new values there, and we can play with it. So be careful with extreme values. It tends to mess up the whole scene. But as you can see, we can change that. Yeah, see, like here, like this. We can change and tweak and try to find the perfect value that fits our scene best. And I'm not going to tweak those because the initial values were just fine. So it's up to you to find the perfect value. I mean, values that fits your scene. Nice. Last one, the stage. So we've seen a bunch of solutions, but it can take some time to set them. Maybe you are in a hurry. The clients really want his model live on the website as fast as possible. You have only, I don't know, like 5 minutes. You can put default stuff. You don't have time. You can use something really cool, which is the stage helper. It will create a few things like minimal configuration, and it will just look good. It's going to be something about environment. It's going to be some shadows, I think, some lights, and everything will just work by default just by using the stage. So yeah, it's shadows, environment map, 2 directional lights, so you get some composition, and it will also center the scene, so you don't have to center the scene, even if your scene has some, I don't know, like tall buildings or wide, I don't know, it's a wide model, it will center everything. Nice. First, we are going to comment everything in the GSX, expect the orbit controls, the perf, and we are also going to comment the meshes. So sorry, it's a bit tedious right now. We need to comment a lot of things. So follow me. We comment the environment like this, the opening and the closing. We can comment the color. For now, I think, no, we can comment the color. We keep the perf. We keep the orbit controls. The accumulative shadows is already commented. The contact shadow, we can comment it. Those are already commented, and we are going to comment those, but keep them close because we are going to duplicate them. You will see why we are not keeping them. We are going to change a few things in those. All right, so right now, I think we have almost nothing. Yeah, okay, cool. We have an error because we are trying to rotate meshes that are not here anymore. So I hope you're still following me. It's a bit hard. You can just follow the video if you want. You're going to see it's not that complicated. So I'm going to duplicate the sphere mesh and the cube mesh. So those ones, we could have just keep them. It's okay. So I'm going to duplicate those. So make sure you duplicate the right meshes, not the floor. So I put them back. So everything is dark, everything is wrong, but at least we don't have the error anymore. The error was because we were trying to animate the cube, but the cube wasn't here in the scene anymore. Okay, nice. So we get something like that. Indeed. Next, so I wanted to show you the stage helper. We're going to import stage, just like that. And it's going to be super easy, you will see. And you just put the stage around your scene. So it's going to be there, stage. I'm going to increment here and close it there and check that. Done. You can send that to the client. Client is happy and you're happy. Everybody is happy. But obviously we can tweak it a little, like if you don't like the intensity of the light or you want to tweak the shadows, etc., you can still do it. But that's so fast and efficient. You can use it just like that to display the model. You add a stage, your model, the orbit control so that you can rotate around and you are done. So first, I'm going to show you some tweaks just so you know that you can do it. We can tweak the contact shadow. So you provide a contact shadow attribute. You send it an object, and those are the same parameters. So if you want to reduce, let's say, the opacity, I think it's something like 0.5 right now. You can do opacity 0.2. Okay, it's less. Nice. Next, we can play with the blur. I like to have quite a huge blur on the shadow. All right, nice. If you want a bigger blur, you can put, I don't know, like 10. It's probably too much. Yes, it's going a little away, so be careful, maybe not too much. Let's put back 3. 3 is just fine. Okay, so we can play with the shadow. There is an environment map, which is used to light the scene. So we can do environment equal, and we can use the preset. Remember the presets we have? We can switch to sunset. I'm not sure it's the default one. Yeah, it's a little different. Okay, so now we have the sunset. Next, about the lights. There is 2 lights by default. There is always 2 lights, I think, in the stage, and they are positioned in a good-looking way by default, but we can change that by setting the preset. So it's the preset of the stage. This is the preset of the environment, and this is the preset of the stage, and more specifically of the lights. And you can set, I don't know, like portrait, and now the lights are slightly different. And I think there are other values, but let's keep those. And you can play with the intensity too. Intensity, I'm going to put 2. Is it higher? Yeah, I think it's kind of the same value. If you put, I don't know, like 10, it's way too bright. If you put 0.5, it's a bit too small. You can't see the lights anymore, but there is still the environment that is doing the trick, so it looks okay. I'm going to put 2, which is a bit too much, but I like bright scenes too. It's just for the example. And we are done. So many cool helpers. I know the lesson was a bit long, but we just discovered a bunch of helpers, and you can use whatever helper you really want. I really like the contact shadow. I really like to use the environment, and the presets are really good. I usually add one more light to the scene just to have really control on the where the core shadow and the light is, and it's super easy to set when you're using Rec 3 Fiber, and more specifically Dre. So it's super cool. We've covered most of the famous and useful solution, but there are more, and you can check that on the Dre repository. So click on the link as always. There is a staging section, and you can see a bunch of staging helper that will make your life easier. It's also about positioning stuff. It's also about camera things. So just check that, read them, just have a look, test them if you want, and yeah, have fun with those. And I'll see you in the next lesson.